Good to come your way once again as we journey through this exciting journey in additional mathematics. My name is Nana Ewedu, and you can call me Sir Nana. Remember to share, like, and comment on this video if you have anything interesting or you find anything challenging you want to ask. And remember to click on the notification bell and subscribe to my YouTube channel so that you can be abreast with all the videos I'll put on the channel. In our previous lesson, we have considered the inverse element of a binary operation under the various operations, which is addition, subtraction, multiplication, and division. In this lesson, we want to look at the inverse element of a binary operation, and we want to basically consider them when we are looking at them with the variables, which is a, x, and y, and to be able to give out a general way of finding it. Now let's look at the inverse of an element. So basically, when we look at the inverse of an element, we are considering the binary operation with variables. We indicate the inverse of an element with a variable. So we say A inverse of A, right? Or we can say X inverse of X. Or we can say M inverse of M. Or we can say N inverse of N. Or P inverse of P, right? So inverses are actually indicated with the variable, for instance, A with the superscript of -1 attached to it. Now let's consider how we can define a general form of an inverse. So we say the inverse element of an element A, so we are considering A in this case, of a set S. Another operation star is an element, so A inverse, which is in S, which is in a set S, and it's such that if I have A inverse and I operate it on A, or the other way around, because it's commutative, right? I have A operation, A inverse, it should give me E, which is the identity element. So where E is equal to the identity element, right? So let's compare it with real variables so that you can understand it better. Let's assume that our operation here is addition, and we are considering the number 7 as our A, right? So our A inverse will be equal to -7, because we know that for addition, if you have 7, we can add -7 to be able to give us 0. So our 0 represents our identity element, right? So we can rewrite this. So our 7 is A, right? -7 is A inverse, and our 0 is our identity. So we can write it as A operation A inverse is equal to E. So a form, or how we can find the inverse when we are looking at it generally in terms of variable, is we can have A inverse operation A, or A operation A inverse, and it's equal to the identity element, right? So let's look at a question that we can solve when we are finding the inverse of an element. So the question says that a binary operation star is defined on the set of real numbers R by P operation Q to be equal to 2P plus 2Q plus PQ. Now we have to find the inverse element of P under the operation star. So let's look at how we can find the inverse element under the operation star. So we can say that the operation that I've been given is P operation Q to be equal to 2P plus 2Q plus PQ. Now remember that for inverse, we are looking at the inverse of P. So P inverse be the inverse of P, right? So such that, right, so we can say such that P operation P inverse is equal to E. Now we know that our E, so where E is equal to our identity element. What this implies is that we cannot find our inverse without finding our identity element. So let's go through the process again of finding the identity element for P under the operation here. So we can say that for identity element, let E be the identity element, right? Such that, so always you must be able to define the E, right? P operation E will be equal to P. So when you have P, it's operation the identity element, it should give us a P. Now let's consider P operation E. Now we know that P operation E, we are considering substituting the P for P and substituting the Q for the E in the operation here. So the P operation E becomes 2P plus 2E plus PE, right? And we know that P operation E is equal to P here. So we'll have 2P plus 2E plus PE to be equal to P. Now let's find our E. We can group like terms, so we'll have 2E plus PE to be equal to P minus 2P. So we have E, we have 2 plus P to be equal to negative P. So P minus 2P will give us negative P. Then we divide both sides by 2 plus P all over 2 plus P. So it means that our E will be equal to minus P all over 2 plus P. So now that we have our identity element, which is minus P all over 2 plus P, we can go on and look at the inverse. So we know that P operation P inverse is equal to the identity element. Now we know E is equal to minus P all over 2 plus P. So let's substitute that there. So we have P operation P inverse is equal to minus P all over 2 plus P. Now let's find P operation P inverse in terms of the general one here. So we have P operation P inverse to be equal to 2P plus 2P inverse plus P inverse, right? And we are going to take this and equate it to minus P all over 2 plus P. So you are going to have 2P, right, plus 2P inverse plus P inverse equal to minus P all over 2 plus P. Okay, so it means that here we can just simply simplify by dividing by 1. Then we cross multiply. So that gives us 2 plus P. We can put into brackets. So we have 2P plus 2P inverse plus P inverse to be equal to minus P. Now let's expand this. In expanding this, all that we are going to do is that we will take the 2, then we'll multiply it over these numbers. Then we'll take the P, and then we'll multiply it over these numbers. So now let's consider that. So we are going to have 2 multiplied by 2P plus 2 multiplied by 2P inverse plus 2 multiplied by P inverse, right? Then we'll take the P. So we'll have plus P multiplied by 2P plus P multiplied by 2P inverse. So you are taking the P and multiplying by each of them. You take your time and do it one by one, right? So plus P multiplied by P inverse, and that will be equal to negative P. So let's expand this. So 2 multiplied by 2 will give us 4P. 2 multiplied by 2 here will give us 4P inverse. Then 2 multiplied by P will give us 2P inverse. Then P multiplied by 2P will give us 2P squared, right? Then you have P multiplied by 2P inverse will give us 2P inverse. Then the last one, P multiplied by P inverse will give us P squared P inverse is equal to minus P. So now that we have this, we can actually factorize all the inverses out. So let's factorize all the inverses out. So we have 4P inverse, right, plus 2P inverse plus 2P inverse plus P squared P inverse, right? Then we'll send all the numbers to the other side. So it's equal to minus P minus 4P here. So here's minus 4P. And then we also have plus 2P squared, right? So that is what it gives us here. Then once we've been able to factorize, let's factorize the P inverse out. So we are going to have P inverse, then that is going to give us 4, right, plus 2p plus 2p plus p squared, and that will be equal to minus p minus 4p will give us minus 5p plus 2p squared. So here we have p inverse 4, 2p and 2p is here, so that gives us 4p. So plus p squared is equal to minus 5p plus 2p squared. So we can divide both sides by the coefficient of the p inverse, which is 4 plus 4p plus p squared. Then we divide this side by the coefficient of the p inverse, which is 4 plus 4p plus p squared. So this cancels this. So we have our p inverse to be equal to minus 5 plus 2p squared all over 4 plus 4p plus p squared. Or we can write p inverse as 2p squared. Let's bring the 2p squared first, minus 5, so that it looks nicer, all over 4 plus 4p plus p squared. So this is our inverse, right? And sometimes because p, we get them, all of them in terms of p, you can be giving p to be a number, maybe -4, and you can put that number into the value of p to get a fraction or probably to get a whole number. So basically in this lesson, we have considered the inverse of a function when we are dealing with variables. Ensure you take your time, go through the process of the algebra, and you'll be able to understand how we find the inverse. So to find the inverse, first we must find the identity element, and then use the identity element to find the inverse. In our next lesson, we want to consider another example of how we can find an inverse, and then we'll move forward to even find an inverse when we are given a particular number attached. Ensure you like, subscribe, share, and click on the notification channel so that you'll be able to get all the videos when I put them there. See you in the next lesson.